Good evening, everyone. Welcome to Grow Up Online Tuitions and welcome to the class of Ncert line to an explanation of haloalkanes and haloarenes. In the previous class, we discussed about the preparations of haloalkanes or alkyl halides. We previously prepared the haloalkanes or haloalkyl halides hydrocarbons from hydrocarbons. So I hope example 6.3 is clear to you. Now let us try to understand within 2 minutes. Identify all the possible monochlorostructural isomers. I am requesting everyone to keep an NCRT with you. I am requesting everyone. Okay. Monochlorostructural isomers expected to be formed by formation of free radical monochloronisation of CH3 twice CH2 CH3. Here now let us try to understand the given question is that the given structure CH bond CH2 bond CH3 and here CH3 bond CH3. Here what they ask, when this reagent is reacted with chlorine, only single monochlorine is replaced by this is replaced by reactants hydrogen radical. So how many types of that isomers are formed? So now let us try to understand how many types of hydrogens are present in the given reactant. Then number of products are equal to that different number of hydrogens. So here we observe that these two carbons are same. We observe that these two carbons are linked to this carbon. So these two hydrogens are also same. So these two hydrogens are categorized as one. Okay. Here CH1 hydrogen is present. This hydrogen is categorized as 3. Here CH2 ikkada sorry. Here these hydrogens are considered as 3 hydrogen. Here the last hydrogen is 4 hydrogens. We observe that this indicates that 4 kind of different hydrogens are present. So how many types of products are there? So there are 4 types of monochloro products are produced. There are 4 types of monochloro products are produced are formed. I hope this concept is clear to you. By knowing of how many different types of hydrogens are present, then the number of products are equal to that number of hydrogens, number of different hydrogens are present. So the total number of so in the given molecule, there are 4 different types of hydrogens are attached. Here is the number 1, 2, 3, indicated with the red one. So the replacement of these hydrogens with the chlorine will give the following compounds. Here is the first one. Here is the second and third and fourth one. I hope this concept, example 6 point is clear to you. I hope everyone try this example. Now let us try to understand today's concept, that is halogen exchange. This is the last second method to prepare the preparation of alkyl halides or haloalkanes. Okay, here halogen exchange. Try to understand this main heading, side heading, that is halogen exchange. That means halogen will be exchanged by another halogen. Here X is replaced by X. For example, in case of halogen, we know that halogens, which means fluorine, chlorine, bromine, and iodine. For example, now let us consider this X may be iodine. So the another X is also an halogen is replaced by fluorine. So iodine is replaced by fluorine. Fluorine is also replaced by iodine. This type of reactions are called the halogen exchange. In this type of reactions, two important named reactions, most important named reactions. That is Finkelstein's reaction and second one is Schwarz reaction, and second one is Schwarz reaction. Second one is called the Schwarz reaction. These two reactions are very important with respect to exam point of view. Now let us try to understand these reactions. Alkyl halides. That means this form of alkyl iodides. This form of iodides are called the alkyl iodides. Are often prepared by alkyl iodides. This form of compounds are often, that means repeatedly prepared by the reaction of alkyl halide. Alkyl halide. Here is the alkyl halide or bromide. In place of X, we take the chlorine. This will be considered as alkyl chloride. If it is bromine, X may be bromine. It may be considered as alkyl bromides. Reaction with sodium iodide in the presence of dry acetone. So we clearly understand that alkyl iodides. These alkyl iodides. These alkyl iodides are prepared by when alkyl halogens is reacted with sodium iodide. Sodium iodide in the presence of dry stone. In the presence of dry stone to form the directly alkyl halides are produced. And so this reaction is called the Finkelstein's reaction. This is the very simple reaction. Here we observe that here X is an halogen compound. Here I is also an halogen compound. So now let us try to understand a small mechanism here. Alkyl halide plus a sodium iodide. We know that sodium is a metal, so it is easily loses electrons off by the so its charge is positive charge. Iodine, we know that electronegativity element, that means I minus. So this compound is shifted toward this side. Why? Because halogens having the high electronegativity. So X minus R plus. This R plus is at this X minus is attracted by R plus. So alkyl halide plus Na plus and X minus. NaX is formed. This is the salt or precipitate. This is the salt is formed. So this is the small mechanism for the above Finkelstein's reaction. I hope this mechanism is clear to you. Now let us try to understand the below matter. Here the formed sodium chloride. Yeah, the sodium chloride, the formed sodium chloride or sodium bromide, thus formed is precipitated in dry ether. Now let us try to understand why we take this condition dry ether. Why? Because here the formed sodium chloride or sodium bromide is precipitated under the dry stone. So we obtain the pure alkyl iodides are formed. We obtain the pure alkyl iodides. That means alkyl iodides are formed. Okay. It facilitates the forward reaction according to Le-Chatelet's principle. You know that according to Le-Chatelet's principle, when the by using of dry stone, it leads to the formation of products. Le-Chatelet's principle indicates that it forwards by this using of this dry stone, it leads to the formation side. That means product side formation, product side reaction takes place. That means product side yield is high. It can't revert back. Okay, I hope this concept that means Finkelstein reaction is clear to you. When alkyl halide, now let us try to recap it. When alkyl halide reacted with the sodium hydride in the presence of dry stone to form the alkyl iodides and sodium halides. Here, what is the use of this dry acetone is that the dry acetone which is used to precipitate the formed sodium chloride or sodium bromide, which facilitate the reaction forward according to the Le-Chatelet's principle. Okay, this is all about the Finkelstein's reaction. Okay, now let us try to understand the Schwartz reaction. This is also similar to the. Now let us try to understand the synthesis of alkyl fluorides. Here, in Finkelstein reaction, we synthesize the alkyl iodides. We can easily prepare the alkyl iodides. By using of Schwartz reaction, we are able to prepare the alkyl fluorides. Okay, we have to remember this point that according to Schwartz reaction, we can easily prepare the synthesis of alkyl fluorides is best accomplished by heating an either alkyl chloride or bromide in the presence of metallic fluoride. In the presence of condition here that metallic fluoride, we clearly observe that metal plus metal and fluoride. Here the metal may be the following ones. Okay, this is the general reaction. When this alkyl bromide or chlorides reacted with metal fluoride, we observe that silver fluoride, mercurous fluoride, cobalt, antimony. These are the we observe that these are the metals. So if they given in the examination, they given in this reaction, this what is the name of this reaction? So here we can clearly understand that. Okay, the given one is alkyl halides. So here the condition we observe that metal and fluoride is undergo takes place. That's why it is the Schwartz reaction. Okay. This is the simple reaction when methyl bromide is reacted with silver fluoride. So we can use any of these metal fluorides, we can produce the this bromine. This bromine is replaced this iodine. So this halogen is replaced by fluorine halogen. So that's why these two reactions comes under the halogen exchange. These two comes under the halogen exchange. Why? Because here bromine is also halogen. Fluorine is also a halogen. This bromine is replaced by this fluorine. This undergoes the halogen exchange reaction to form the methyl fluoride plus silver bromide is produced. I hope these two reactions are clear to you. These are very, very important with respect to exam point of view. Okay, I hope this video is clear to you. If you find any difficulty in understanding or if you find any conceptual confusion, please contact to me and please share with you if this content is useful to you. If and only if this content is useful to your studies, please do subscribe for more videos and updates and please share with your friends and family members. Thank you and all the best.